Welcome to the Level 1 video on solving systems of equations. We are going to be looking at a particular system with two equations and two unknowns. The system is 2x minus y equals minus 4, and we'll call that equation 1, and 4x minus 3y equals minus 10, and we'll call that equation 2. We're going to be solving this in three different ways, but we're going to start off solving it using substitution. So if we solve equation 1 for y, so rearranging equation 1, we get that y is 2x plus 4, and we can go ahead and call that equation 3. Then substituting equation 3 into equation 2, gives us 4x minus 3y, but remember y is 2x plus 4. This is equal to minus 10. Then we can multiply this out. Of course we have 4x still, but now we have minus 6x minus 12, still minus 10. Then we simplify this further and we've got minus 2x is equal to 2, which implies that x is minus 1. Now if we substitute x equals minus 1 into equation 3, we get that y is 2 times x, which is actually minus 1, plus 4, which is 2. So we have that x is minus 1, and y is 2. Of course, this is a simultaneous equation, so we can check our answers easily. So let's go ahead and do that. So the original system was 2x minus y equal to minus 4. We've got x to be minus 1 and y to be 2. So this is actually minus 4. And the other equation was 4x minus 3y is minus 10. So that's 4 times minus 1 minus 3 times 2, which is minus 10. So both of those correct. And let's solve the system using the next method, which is elimination. So let's remind ourselves quickly of the system. 2x minus y was minus 4. Let's leave that as equation 1. And 4x minus 3y is minus 10. That's equation 2. So if we want to eliminate the variables x and y, let's eliminate y first. And you'll see that we've got minus 1y in equation 1 and minus 3y in equation 2. So let's take equation 2 and take away 3 lots of equation 1, and this will remove the variable y. So we have 4x minus 3y minus 3 lots of 2x minus y, and that's equal to minus 10 minus 3 lots of minus 4. So we can multiply this out and get 4x minus 3y minus 6x plus 3y is 2, and then our y's cancel, which is what we wanted, and we can simplify this a bit further and get 2x is equal to 2, which implies that x is minus 1. Now if you want to eliminate the variable x, take equation 2, and we can take away 2 lots of equation 1. This gives us 4x minus 3y minus 2 times 2x minus y, which is equal to minus 10 minus 2 lots of minus 4. Multiplying this out, we've got 4x minus 3y still, minus 4x, which is looking promising, plus 2y is equal to minus 2. So this time the x's will disappear, and we're left with minus y equals minus 2, which implies that y equals 2. And this is consistent with the substitution method, so we know we've got it right. So we can move on to the last way we're going to solve this system, and that's by formulating it as a matrix system. So let's go ahead and do that. So once again, let's quickly remind ourselves of the question. 2x minus y equals minus 4, and 4x minus 3y equals minus 10. First of all, we want to write this in terms of a matrix equation. So we take the coefficients of the left-hand side here and write these as a 2 by 2. So 2 minus 1, 4 minus 3. We multiply this by our solution, x and y, and it's equal to the 2 by 1, minus 4, and minus 10. Now if we call this matrix M, and we call this x bar for our solution, and we call this 2 by 1 capital A, then if we were to calculate M inverse and multiply the left-hand side and the right-hand side by M inverse, we would have M inverse times M times x bar equals M inverse times A. Then we know that M inverse times N is just the identity, so that x bar is just M inverse times A. So to solve this, we just need to calculate M inverse and multiply it by the 2 by 1 matrix A. So let's go ahead and do that. So the solution, x bar, which is x and y, is M inverse, which is 1 over the determinant. So we've got minus 6 plus 4. Then the 2 and the minus 3 swap places, and the minus 1 and the 4 are negated. We multiply this by capital A, which was the 2 by 1 matrix, and that's our solution. So let's multiply this out. Minus a half, 12, minus 10, and 16, minus 20. So we have minus a half, 2, minus 4, which gives us 1 and 2, which means x equals minus 1 and y equals 2, which is consistent with the substitution and elimination methods. So we know we got it right. Thanks for listening.